So yeah, so you've noticed that some of our robots have cameras on them, and up to this point, we've been looking at how to teach the robot to perform certain tasks, really as if it were kind of like a blind machine. So almost like you're leading it by the hand, and you're telling it to remember a position, and then you're recording that, and then. And then you've been using this process to also develop like tool frames, jog frames, user frames, and that kind of thing. And if you wanted to teach the robot to grab something, you would have to teach the robot to put its grippers, in a particular position and the relationship to the part. And the part would have to be like at a predictable place in order for that to all work. Otherwise, if the part wasn't oriented the same way the second time, then maybe the grippers wouldn't be able to grip the part and that wouldn't work. So what we're going to see is that by adding visioning to our robots, that we would be able to have the robot see the part and orient correctly, pick it up, or many other tasks, but that would be an example of what we could do with it. So I'm just going to do a little introduction to single visioning, single visioning processes here. And then I'm going to describe a procedure, a simple procedure for just having the robot snap a picture and find a particular object. And then I'm going to also give you some handouts. It's a way for you to get your feet wet in visioning. It's not going to be a real difficult process. It's really just one of snapping a picture, having the robot snap a picture and find an object. And then we're going to go into the lab, and then I'm going to just demonstrate how that process would work. So any questions before we get started? All right. So really the process that we have, or one of the things that we have to set up beforehand is we have to have a camera sequence. And so that has been added on our collaborative robot, it's mounted to the arm itself, and then on our other robots, it's mounted in a fixed position. And the camera that we're going to be, or the robot that we're going to be using, the camera is in a fixed position. And that camera is going to have to be connected to either a PC that would have software on it that could develop these processes, or we could use our teach pendant. So we're going to be using the teach pendant this morning, and I'll show you how that works. So let's see. One of the things. So I've already mentioned one of the things that this robot can do to help it. I mean, adding visioning, how it would help it grip the part. But can anybody kind of just kind of imagine what are some of the other things we could use? What are some of the ways we could use visioning? What advantages would it really offer to the process?
Well, it could tell if there's a part there or not.
Just the snap and find process, it could just tell you if the part's there or not. Any other?
Tell if a tool's broken or something like that.
I think that's.
Tell if a tool's been broken.
You can tell if the tool has been broken. Yes, actually, it could. It could. Maybe it could have been taught to move its gripper arms in front of the camera to check something. Maybe check, see if the grippers were still in good shape. Any other ideas? Yes.
You can tell what's the speed of the object coming in?
I think that may be true, but I can't tell you where or not. I'm thinking it. I'm not sure.
You can tell if it's the right part.
It could tell if it's the right part. Sure.
So that you can detect an anomaly or objects even that it has to avoid.
Yes. And if it was picking parts, maybe it's looking for a defective part and pulling the defective part out. So being taught what a good part looks like. So I have a little video here, or a link to a video that's really going to kind of describe all these things about picking parts, inspecting, and assembly. So it's only a couple of minutes, and it's done by sure if I have sound. know whether or not,
We don't, you just turn the knob up.
oh, I see.
There you go.
Okay, well, sound actually isn't all that important in this video, so we're just going to go ahead and play, and I'll just describe what's happening. So this is a little bit, this is a different type of robot than ones we have here. So, and what the process is going to be is the robot's going to kind of assemble bolts into an engine. Actually, it's just going to place bolts into an engine. So this is kind of what the process is going to look like. The first thing that it was doing was it's going to be setting bolts into a rack. So then it's going to grab those bolts from the rack and put them in place in the engine. So this is how the process works. So those are bolts sitting in the tray. And it's lining them all up and getting ready to assemble. And as it's doing that, it's kind of hard to see, but it's passing by a camera and snapping it to make sure the bolt, just check it to make sure the bolt is okay. And so it's measuring the length of the bolt, and it's making sure that the bolt went down one that was too short, so it's starting to go out. And it's now assembling it, or it's dropping the bolts into the holes, which probably holding those are probably bolts that are holding the head down to the assembly. So, and that's basically it. So this is going to repeat that process. All right. So it gives you an idea. That's way more complicated than just teaching a robot to move from point to point. Although for a lot of manufacturing, that actually is just good enough. As we're really adding this new layer of automation in manufacturing, more and more we're going to need visioning in order to carry out really complex processes of just think of sewing a garment or assembling complex assemblies. Visioning would be all right. So the process I'm going to teach you is the process I'm going to demonstrate today is, like I said, it's a very simple 2D view process in which we're going to identify an object that we want the robot to recognize and make for it. And it's going to be our camera's already been calibrated, and I've got to bring a calibration grid. Maybe we'll look at when we go into the robot. But basically, we have a calibration grid that we're going to have the robot snap a picture of. And the dots, these dots on this grid are on 30 millimeter centers, like really precisely. And what we're telling the robot, it's more complicated than this, but basically what we're telling the robot is that these dots are on 30 millimeters centers. And so look at this and remember this, and it has to do with the pixels and the camera and all this, but it's going to then calibrate itself so that when it sees this kind of distance, it knows, what that distance is. And so after the camera has been calibrated, it actually can be used, as we saw in the video, to measure the length of a bolt and make sure it's like within a tolerance. Give it a tolerance. It didn't make that tolerance. All right, so we're not going to do this process. We're not going to do calibration today, but because the camera's already been calibrated, that's what I'm talking about. So I'm going to kind of quickly go through this procedure, and I want to hand out this. Procedure sheet so that you all have a copy of this. If you could pass a few of those back, and if you could kind of pass those down that way. So this is kind of a simple step-by-step procedure on how this is going to work. Just kind of a reminder, and at the very top of that sheet that I just handed out is a link to a YouTube video in which I filmed this whole process so that if you don't remember exactly what I'm talking about today, you can review the film, and then hopefully with these step-by-step instructions, you should be okay. So, but basically, we're going to go to the main menu, and we're going to tell it that we're going to we're going to develop a vision, we're going to use vision process tools, and we're going to create a new 2D single view vision process. And then we're going to make sure that's selected, and then we're going to give it a name, and we can put a comment in there if we wanted to, although it's not necessary, but it does need a name. And then once we've created that, it'll show you, once you press OK, it will have that new vision process ready for you to edit. So that would be the next thing. You would edit the process. And then once we get to this screen, so like I said, it's going to be hard to see this on the teach appendix, so I'm kind of just running through this. I can make this, I can also make this PowerPoint ready to go. We're going to click on the tree, and we're going to select the 2D single vision process. And then we're going to go over to the, on the right side of the screen, we're going to select the calibration. Select the camera calibration file so that it's ready to be used in this process. And then we're going to then click on the GPM locator tool, right there, and we're going to press snap, so then we'll take a picture. And then we're going to teach. So then we're going to teach the robot what it wants to look at and remember. So then we're going to get this little window will appear on the screen, and we'll get a window around the part. And I'll just tell you right now in that teach appendix, when we look at the number key, so you look at the number keys on that teach appendix tab, and there will be numbers 1, 2, 3, 4, 5, 6, 7, 8. And these numbered keys will correlate to the little dots on the box here. So if we wanted to move this wall of the window over, we'll probably select key number 4, and then we'll use the cursor key. We'll move that over, and then we're going to continue that process till we get that. That entire part that we wanted to recognize, recognized, and then we'll press OK when we're done.
Now, does it matter how close you adjust it, or just has to be on that?
Well, we would probably window around as carefully as we can, but it doesn't have to be terribly exact.
Okay.
It'll recognize that there's this kind of space there that's not important, or just looking at the lines of an object.
Okay.
But we wouldn't want any other objects in the picture, because it would, if there was a partial, maybe just a partial piece of an object in that picture, then it would look for that too. It would mean that whole thing. So good point. Yeah, we do want to. And so we'll go out to the lab, and then we'll